Hey guys, okay, we're finally on 4.6 where we're talking about inverse trig functions. All right, so one thing is, remember, what do we know about inverses? Remember, to have an inverse, an equation or a graph has to be a one-to-one, which means it has to pass the horizontal line test. If you look at the graph here of sine of x, you can see that it does not. So if I drew in another line here, it does not pass it. So therefore, we're going to have to restrict this graph on its domain so that it will have an inverse function. And so we're going to pick two x values to restrict it between, and we use negative pi over 2 to positive pi over 2. If we look at just that section of the graph, let me increase my eraser size here to hurry this up a little bit. All right, so if we look at just that part of the graph, it does pass the horizontal line test and it does have an inverse. All right, so it says here on part 1, a note of caution. It says recall that the function f is an inverse function that if no horizontal line intersects the graph of f in more than one point. And so then it talks about that sine of x, and it talks about how using the original one that no inverse would exist, but we restricted our domain, and therefore now it is one-to-one and it has an inverse function. And so we're going to do the same thing to all of the trig functions, but we're not going to sit here and draw them all out. So if you look at part 2, it's going to have a table here. Okay, so in our table here, we first see our function, and I'm going to go through each of these with you. So first we have y equals sine of x. If you're going to write it as an inverse, you write it as y equals the inverse sine of x, where the little negative 1 is right there after the sine, or you can write it as y equals the arc sine of x. They mean the same thing. If you see inverse sine or if you see arc sine, they're both talking about the inverse. All right, but remember, the big thing with inverses is we switch the x and y. So this means the same thing as if I'd have written that x is equal to the sine of y. And then it talks about its domain. The domain for the inverse sine is going to be negative 1 to 1. And the range is going to be negative pi over 2 to positive pi over 2. Because remember, if x and y switch, domain and range switches as well. And for sine of x, we had a domain that was negative infinity to infinity, but we had to restrict that to do the inverse. And we had a range that was negative 1 to 1. So we had to switch them, and we restricted the domain right here so that it was only negative pi over 2 to pi over 2. All right, same thing when we look at cosine. Its inverse is going to be y equals the inverse cosine of x, or we could write it as y equals the arc cosine of x. Okay, remember we switched the x and y, so what that really means is that x is equal to the cosine of y. Our domain for the inverse cosine is also negative 1 to 1, but for the range, the way they separate it is our range is going to be from 0 to pi. And then we have tangent. So y equals tangent of x. The inverse is y equals the inverse tangent of x. Or we could say y equals the arctan of x. But what that means then is x is equal to tangent of the y value. So all of these, by the way, when we're looking for the x equals the tangent of y, x equals cosine of y, x equals sine of y, we're looking for the angle. And so on here, domain and range is also going to switch. So for tangent, our domain is now going to be negative infinity to infinity. And our range is going to be negative pi over 2 to positive pi over 2. Now notice that's in parentheses this time. That's not inclusive. Negative pi over 2 and positive pi over 2 do not work, because that's where the vertical asymptotes are. All right, and then it talks about the reciprocal functions. So we have y equals cotangent of x is the next one they talk about. So we could write that as y equals the inverse cotangent of x, or y equals the arc cotangent of x, which all that means is that x is equal to cotangent of y. Its domain is going to be negative infinity to infinity. And its range is going to be 0 to pi, not including them. Then we have y equals cosecant of x, which the inverse is written as y equals the inverse cosecant of x, or y equals arc cosecant of x, which just means we're going to switch our x and y, so x is equal to the cosecant of y. It has a domain of negative infinity to negative 1, and from 1 to infinity, and it's got a range of negative pi over 2 to 0, not including the 0, and then not including the 0 up to pi over 2. Sorry, I'm running out of room there. And then our last one, I'm going to have to write a little smaller, I think. So we got y equals secant of x. Its inverse is written as y equals the inverse secant of x, or y equals arc secant of x, which just means that x is going to be equal to the secant of y when we switch x and y from the beginning one, the original function. Okay, I'm going to write its domain under it, and I'm sorry, I know I'm at the bottom of your screen. So its domain is going to be from negative infinity to negative 1, and from 1 to infinity. And its range is going to be from 0 to pi over 2, not including the pi over 2, and then the pi over 2 to pi. Okay, so we've got those down. Of course, they were already in your notes, but I just kind of went back over them there. But remember now, inverses have to be 1 to 1. Inverses, so we switch our x and y. And then at the bottom is showing us the graph. The bottom of our page is showing us the graphs of it. So remember also, inverses are reflections across the line y equals x. So if you look at those graphs, the first one's just showing you that sine and the inverse sine are reflections across that line. Second one is the cosine and the inverse cosine are reflections across that line. And the third one shows that tangent and the inverse tangent are reflections across the line y equals x.